Hello and welcome to this introductory video for chemistry at National 4 level. And because it is introductory, I'm going to assume we're working at ground zero level here, and I'm not going to assume that you know anything so far. Okay, we talk a lot about substances in chemistry. So let's be clear what we mean when we talk about a substance. Take air. Now, air is not a substance. We talk about fresh air. We talk about clean air. This is a lovely picture down the Forth Valley taken from the Wallace Monument. The air was lovely and clear up there. But we don't talk about pure air because air is not just one substance. It's a mixture of gases. There's a nice pie chart there showing you the gases in air. Notice mostly nitrogen, a fair chunk of oxygen and other gases. But it's a mixture. It's not just one substance. It's a mixture of substances which we could separate out. If we separated out the nitrogen, we couldn't separate it out further. We would have just one substance, nitrogen. You can't unmix nitrogen because it's only one substance. Similarly, you can't unmix oxygen. If you take oxygen out of the air, you can't unmix it further. It is one substance. Likewise, carbon dioxide. If you separate out the carbon dioxide from the air, you can't unmix carbon dioxide because there's only one substance. There are lots of things like that. Mineral water, for example. Mineral water is a mixture of water and other substances. If you take just the water out, you can't unmix water further because it's only one substance. Okay, so what can happen to substances? Well, we can talk about physical changes. Let's, for example, take a cube of sugar. What could you do to a cube of sugar? Well, you could smash it to bits, in which case you'd finish up with a little bit of powdered sugar. But it would be powdered sugar. It is still sugar. We haven't changed the substance itself. It's the same substance, just in a different form. A moment ago it was a cube and now it's a whole bunch of powder, but it's still sugar. Or we could take the same cube of sugar and dissolve it in tea to make the tea sweeter. But it would still be sugar. We know it's still sugar because it makes the tea sweet. So again, you haven't changed the substance. You've just mixed it in with something else. In this case, tea. What else could you do to sugar? You could melt it. You could turn it into a liquid and finish with a liquid pool of sugar there. But again, it's a pool of sugar. It's the same stuff, just in a different form. And when that puddle cools down, it's going to freeze. It's going to turn back into solid sugar again. It's the same substance, just in a different form. So these are all what we call physical changes. Examples are change of shape. If you change the shape of something, it's still the same substance, you've just changed the shape of it. Change of state. That's things like melting, freezing, evaporating, condensing. When you do these things, it's the same substance, just in a different form. Ice, for example, is still water, just in a different form. Steam is still water, just in a different form. Mixing too is a physical change. When you mix things together, you still have the same substances, they're just intermingled with each other. And there are often ways of separating them quite easily. So the key point here is, in a physical change, the substance itself doesn't change. It's just a change of form. We're going to compare that with chemical reactions. Okay. If I was doing this as a demonstration with a real-life class, this is the sort of thing I might do. I might take a test tube and put into it some copper carbonate. Now the thing about copper carbonate is it is a blue-green colour. Aquamarine, turquoise, call it what you like. It's a blue-green colour. And it's a solid, it's a powder. So we know this about copper carbonate. It's a blue-green powder. Hold on to that. It's going to be important in a moment. So we take our copper carbonate, a blue-green powder, put it in a test tube and put the test tube into a clamp and stand, which I honestly can't be bothered drawing. And then we're going to put a stopper and a tube into that and bring in a test tube with some water. Okay, now what we're going to do is we're going to heat the blue-green solid copper carbonate. So we bring in a Bunsen burner and we heat it. After a few moments, you start to see bubbles appearing out of the delivery tube. Now, bubbles are gas. Now, copper carbonate we know is not a gas. So whatever that gas is, it's not copper carbonate. It must be something else. We have to work out where that something else has come from. But not only that, along with the bubbles, the powder changes colour and goes black. We finish with a black powder. Now, whatever that black powder is, it can't be copper carbonate, because we know that copper carbonate is blue-green. This black powder must be something that wasn't there before. So we do some clever little tests, and we find out that that gas that was produced, those bubbles, are in fact carbon dioxide. So where's this carbon dioxide come from? And if we test that black powder, we discover it's actually copper oxide, a different substance from the one we started with. So what's happened here is the substances have actually changed. We started with copper carbonate, but at the end we didn't have copper carbonate anymore. We had carbon dioxide and copper oxide, different substances. And this is what makes this a chemical reaction. In a chemical reaction, we start with one lot of substances that we call reactants, and they turn into different substances that we call products. And that there, copper carbonate going to carbon dioxide plus copper oxide, that is an example of a word equation. So how do we know if a chemical reaction is going on? Well, we've seen a couple of hints here. A colour change. If there's a change of colour, it implies there's a new substance being formed. Similarly, if a gas is produced, unless there was a gas there to start with, then that gas produced must be a different substance, implying a chemical reaction. Also, often in a chemical reaction, you'll get a change of temperature. Some chemical reactions release heat, making things hotter. Some take in heat, making things colder. Okay, so to sum up, we talked a bit about physical changes. Now, the key point in a physical change is that you have the same substance at the end as you had at the beginning. It's just in a different form. Examples might include changes of state, that's evaporating, condensing, melting and freezing. Mixing, any kind of mixing, including dissolving, is simply a physical change. And anything that just changes the shape of the substance is a physical change. We compare that with a chemical change. In a chemical change, you finish with different substances from the ones you had at the beginning. So one lot of chemicals changes into another. We say that reactants turn into products. And we often spot a chemical reaction by looking for a change of colour, or a change of temperature, or a gas being produced. Okay, now the hardest thing to understand about this is the idea of a chemical reaction, that you're actually making substances that weren't there at the beginning of the reaction. Once you get that, understanding chemical reactions will become a lot easier. For the moment though, that's it. Bye for now and thank you for watching.